Classify the critical point 0, 0 of the given linear system by computing the trace, tau, and the determinant delta, and using figure 11.2.12, which is this one over here, which you'll see in a second. How it works. So, the first thing that we want to do to find the trace and the determinant, and don't be scared about it, it's actually pretty straightforward, is we want to rewrite this as a matrix in matrix form. So we have our x and y prime, and that's going to be multiplied by the coefficient matrix -5, 3, 2, and 7, and by the vector x and y. Now that we have this is the matrix that we're interested in, coefficient matrix. And if you need a little bit of a review, just remember that this really looks like this system over here, which we solve by finding the eigenvector. This is the eigenvalue problem. And you know why? Well, it's because if I guess something like k e to the lambda t, just randomly k e to the lambda t, and I plug it in here, well, if I take the derivative and I assume that the k is constant, I'm going to have lambda k e to the lambda t equals to a times k e to the lambda t. So now what we want to do is we take this away, that'll never be 0, and then we realize that this is asking the question, what matrix applied to a vector gives me the same thing as just scaling the vector but doesn't knock it off of its span. And so what we can do is I flip the equation, I can put an identity matrix here just to make it matrix multiplication both on the left and on the right. And then I can say A minus AK minus lambda IK equals 0. And I can factor out this K, which means I'm going to get A minus lambda I times K equals 0. And this is the eigenvalue problem. So this is what we're trying to find right now. So now that we have our A, we can say -5, 3, 2, and 7. The trace is going to be the sum of these two numbers, and this only works for a 2 by 2. The trace, therefore, is going to be -5 plus 7, which is 2, and the determinant is just going to be the product of -5 times 7 minus 3 times 2, which is going to be -35 minus 6, which is going to be -41. Since this is negative, we can say that this is a saddle. And you can look over here. This is your discriminant. The discriminant is negative, so it really doesn't matter what the trace is. It's going to be a saddle. All right, I hope this was useful, and I'll see you next time.